This is part 2 of the overview of the design tool for inventory and monitoring, or DTIM. So the next step, after you have added your objectives, you've decided on the list of questions and the metrics, then you want to go into the tab labeled Constraints. This information will inform the inventory design and the planning for the frequency of monitoring and reporting. So most of these questions are yes or no, so you can simply just put in a Y or an N. You'll want to go through this list of questions with your team and decide if your inventory system will need to generate maps from the results. You'll want to think about the population of interest and the area size, different funding constraints that you may have, and other design factors such as areas that may be non-sampled due to difficulty with access or permission. Once you've gone through this tab, then you can go into the Area Info tab. On this tab, you want to put in the area of the population that you've discussed in the previous tab here. Then you want to put in the actual number of plots that you may already have. And then often there are not enough existing plots to adequately estimate the values and their sampling errors, so you may need to add in additional plots from surrounding areas that will be needed to compute the sampling error. So I put in a number of 359 actual plots from an example I'm going to use in the later tabs. Then we want to think about the remeasurement cycle. In the US, we measure on a 10-year cycle, so the plots are remeasured every 10 years. But you may have a requirement for more frequent remeasurements for different reporting. So you can change this number for whatever is required for your program. Then you may want to think about whether or not you want to create an annualized or a panel of plots that are measured on that are a subset of the larger plots that are measured annually. So again, we do this in the US where all of the plots have been panelized and are measured, and a subset is measured annually, and this is all completed again on the 10-year cycle. So I put this here. This could change, or you could just leave it as 0 if this is not what you're going to be doing. Then we want to go into this tab labeled CV by strata, or coefficients of variation by strata. So if your population of interest has a lot of variability, which many national forest inventories do, then you will want to partition your total population into subpopulations based on specific characteristics, or into stratum. So in this example, I have included the stratum that is used in Lao PDR here, which are different forest classes with unique characteristics. And I have also put in the area size of each of these stratum into this table here. I have put in the sample size of plots that they currently have in each of the stratum. And then I've looked into the existing data in which they have for carbon stocks by these stratum. They are forest classes. And I've taken the mean of the carbon stock and the computed standard deviation, and I have put those into this table here. This gives you the coefficients of variation in this column here, which is basically just the standard deviation divided by the mean. And then this tool computes a sampling error, which is based on the area size divided by the coefficients of variation by stratum by the mean squared divided by the sample size. And then it takes the square root of all of the totals and divides them by the total area size. And we get a sampling error here of 2.3. So this will be used in the next tab on the precision tab here. The precision tab is a very important tool tab in the DTIM tool that creates a list of tables of the selected metrics by categorical variables. To populate the sheet, you first want to make sure all of your selected objectives, questions, and metrics are active. So to do this, we'll want to go into the questions tab and make sure the ones you want to look at are active. Check your questions that are active. So you'll want to, if they are not all active, you may want to click on the button here that says Show All Rows. And you'll want to look at the Metrics tab. So we, again, will put Show All Rows to be able to look at all of the metrics at once. Okay, once we have done that, we'll go back here and we can click on the green button that says Click to Append New Tables. So as you can see, this lists all of the possible tables based on our selected metrics. So I would like to look more into the overall carbon balance. Since we have entered the data in the previous tab, the coefficients of variation tab, I want to go and look at this table on carbon balance, because this table may be important for monitoring. So it's important to think about which tables are critical for reporting and maybe critical for deciding what your overall sample size of plot should be. So I'm going to look at this one a bit more. So there are currently 5 different metrics listed under carbon balance. To separate these metrics, you click on the yellow button here that says click to separate list into metrics into separate rows. So this separates the metrics into subtables that we want to look at. So we were looking at carbon stock. So we want to go and so we have, so you can see here there's metric 33. So we can go into the table below, which has populated, basically has divided the overall tool into 2 tables. And it pops up the attribute tab here to be able to better look at and reference the metrics and the lists of categorical variables. So we can look below at the list of metrics. This has selected 33, which is removals of biomass. That's not the one we have the data on, so I'm going to keep looking at the other metrics here. We have 37, above ground carbon of all live trees. So this is the one that we have data on, so we're going to take a look at this one. So we want to, again, we want to click on this row here, and then the yellow button, separate this into a subtable. And now we want to figure out what we want to, what the categorical variable should be for our table. So the existing data or the existing table that is of importance to this example is looking at overall carbon by forest type or forest class. So we're going to say, okay, let's look at this by forest type, which is 34. So 34 for the categorical variable here. So we want to select 34, we want to put that in this row here. Whoops, not there, here. And this selects it on this attribute tab below here. The next is to put in a number in the column tab, which is basically only used if we want to create a two-way table or have multiple categorical variables. Same with page references where it was found in the attribute tab. And then you can put in the cell in the table defined in the left if you need that, although we'll just ignore those at this time. You can put in the scale of the table that you want to report on. Could be at forest, could be at ecoregion or subsection, or district, if that's your population of interest. Then you want to put in your confidence level required for reporting. So this table has at 68% is just what it is set to populate all of the tables, but if there is a requirement for a higher confidence level, then you can change this. So you can put in here. So in this example, the required confidence level to report out carbon in Lao is at 90%. So we want to change this to 90% here. If you wanted to change all of the rows, you can actually do that by unhiding this row 3 here, and then you can change this row here, and if you were to create other tables, it would duplicate that below. So I'm going to go back and same with the confidence level half width. So I'm going to go and hide that. But right here we'll put in 90%. And you can put in the confidence interval half width, which is the percent that is plus or minus the confidence level. So the higher the confidence level percent, the larger the required sample size will be. And then the lower the confidence interval half width, the higher the required sample size will be. I'm going to leave this, in this example, at 15% here. So then we want to put in our current sample size. So this was in the area info tab at 359. So we'll put in 359 here. And then the sampling error for this table, which was computed at 2.3%. So we want to put this here. Whoops, not 2.3. So once you put in your sampling error, this table populates the sample size that is required to obtain these confidence levels that you have put in. And you'll also want to, if this table is important for reporting and is important for your forest inventory program, then you'll want to activate this table. So you want this required sample size to feed into some of the next tables. So the next tab on this tool is the attributes tool, which is also below here. And then we have the tab labeled sample sizes, which here we have the current number of existing plots, which is taken from the area info tab, the required total number of plots. This has the expected number of plots available. It gives you, basically, if you put in a cost per plot, it will calculate the overall cost per year of your sample size. And then you can also, it will include your other information that you put into the other tabs, such as the remeasurement cycle. If you were going to be breaking that out into an annualized inventory of a panel per year, it would include that into the breakdown of costs per year. And then it gives you also gives you a total plot cost per cycle. You can add in your other costs here for planning, data processing, analysis, administration, indirect costs here, which will go into the overall costs. And it gives you the required sample size. This is right now only at 11, only because we've just gone through just one example here on the precision tab. And there is a tab here with the allocation by strata. On this tab, you can input your stratum information and then your sample size and the mean standard deviation of your sample to get the computed coefficients of variation. You can also put in a cost per plot, so you can change this for different stratum. If some stratum are more difficult and costly logistically, then you would want to change the cost here. And this gives you a proportional allocation of your sample size on these different stratum into 3 different options. So the first option is proportional allocation, like we have in the US. And this takes the total sample size and proportions the sample size based on the stratum area here. Then there's the Niemann allocation, which proportions the sample size to minimize the variance. And so it includes the standard deviation that's computed here. And then you can also, the option 3 is optimal allocation, which incorporates minimizing both the variance and it incorporates the cost per plot, which is helpful again if you have some stratum that are more remote and costlier than the other stratum. So this tool may be helpful in proportioning your sample size by the stratum. And that is the last tab that is important to use for inputting your information. Here I have just some data, and then there are the codes tabs that are used in the earlier than the other tabs in this tool. So thank you for listening, and let us know if you have any questions.